in 3.11, our objective is to be able to solve quadratic inequalities. So inequalities, we need to review what that means. So in inequality notation, we're talking about greater than or equal to. So we have greater than or equal to. The equal to ones have the line underneath. And then we have greater than, which is without the line underneath. Less than, which looks like a squashed L, less than or equal to. And then we have less than. And then how we see these in a graph notation, and this graph we're only looking at number lines. So a number line, which is just a one-dimensional graph, that is how we're going to be solving our inequalities today. So graph notation, when we see a greater than or equal to, so we'll have a closed in circle, a filled in circle, because it has the equal to part, and then greater than is going to be in that direction, because on a number line, all of our positive numbers, our big positive numbers, are to the right. Greater than, just greater than, is going to have an open circle, move to the right, because we have to use the graph, because the equal to, when we solve these, it's going to be a set of numbers. It's not just going to be one number, but it's every number that's greater than a specific number. So then we have less than or equal to. Equal to means we have a filled in circle again, but it's going to go this way. Less than is going to be an open circle going this way on the number line. Okay, and then we'll be using inequality notation, but we'll also be using interval notation. And so when we have like equal to numbers, so if our set is like all of the numbers between 3 and 4, including 3 and 4, we use brackets. So it's brackets, your lowest number first, comma, your highest number, and then bracket if you have equal to on both sides. On the graph notation again, is a closed circle. Anytime it's an equal to, we used closed circles. But then if it's not equal to or not including those end numbers, we're going to be using a parenthesis. And even when we use infinity or negative infinity, we use a parenthesis. I just think about it as like there's no way we can include infinity, so I just used a parenthesis for that. And then in graph notation, not equal to is just an open circle. Okay, so for the warm-up, maybe you want to listen or watch one of these and then try the rest of yourself. Pause the video at any time and try some of these before we go through them. But inequality notation for this one. So we have a filled in circle, meaning that one's going to be an equal to on that side. This one is going this way forever, all the way to negative infinity. So then that's going to have a parenthesis, right? Because we can't include infinity. So when we're looking at interval notation. So inequality notation, that is a less than or equal to. So we're looking at an x-axis, so I'm just going to use an x. So we're going to say x represents all numbers that are less than or equal to -2. So that's all we have to say on that one. So interval notation, though, we have to say like the lowest number and the highest number in each interval that we're looking at. So for us, the lowest number is negative infinity, but again, we cannot actually include negative infinity, so that gets a parenthesis, comma, our highest number all the way on the right side, which is -2, and we are including -2, so that side gets a bracket. Okay, go ahead and pause the video and try these next ones. This one's going to look a little bit different because x is between two numbers, so we have to have x in the middle, and this time we're going to have two less than signs. So this one's going to be less than or equal to because we have a closed circle over there on that side. We're just going to have a regular less than because that's an open circle over there. But on this one, we go from left to right. So we have -3 is less than or equal to all of our x values, which is less than 4. So we put that all together in one inequality, and you can only do that when it's one chunk of the graph. In interval notation, same idea. We do our lowest number, which is -3, but since it's filled in, we are including, or it's equal to -3, so that gets a bracket, comma. Our highest number is 4, but that has an open circle, so we're not going to include it. That gets a parenthesis. The third one, we have two different pieces here, so we have to write two different inequalities. So we write one inequality for this section over here. So we say x values are, we have some x values that are less than or equal to, since it's filled in, -3. Or we have to use the word or this time, or x is greater than 4. Since we have two different pieces, we have to have two different sections in our inequality and in our interval notation. So for the first interval, our low number is -infinity, right? Because it goes all the way to the left, which is -infinity on the number line. And then highest number of that piece is -3, including -3. And in interval notation, we use what's called a union. And it looks like a U, but there's no tail. It's just a U. And then we do the next piece, which is parenthesis 4, because we're not including 4, all the way to +infinity, because it goes all the way up to the right to +infinity. And that's our interval notation for that one. Okay, so we're going to use these methods and notations to write our answers as we solve our quadratic inequalities. So here are the steps to solve a quadratic inequality algebraically. So step 1, you get 0 on one side. We're only going to have one variable this time. It's just x. That's why we only have one axis that we're working with. So get 0 on one side. Hopefully that sounds a little bit familiar. And then we're going to solve the related quadratic equation. So we're going to kind of pretend that it's an equation for a second. Solve that using factoring. And then whatever numbers we get from that, we're going to use in step 3. So we're going to set up a number line with the solutions from step 2. And then, because these are inequalities and not equations, we're looking for not where this side is equal to that side, but where is it greater than that side. And so we do have to look for intervals of numbers, not just one specific number, but intervals of numbers that will work. So we have to, next we're going to have to pick a test value in each interval to determine the sign of the expression over each interval. This will make more sense as we do some practices. And then once we do that, find our solutions, we write the solution in both inequality and interval notation. So how this works, this is actually already factored for us already. So like step 1, it's already equal to 0. We got 0 on one side. Step 2, solve the related quadratic by factoring, but it's already factored. So we're really on to step 3. So factoring, but I guess there is one more step. So factoring, remember when we get to this point, it's equal, either this one equals 0 or this one equals 0. So that will end up being x equals 2 and x equals -10 when we solve those. So those are the two numbers we're going to use when we set up our number line. So we're on to step 4. Oh, step 3, sorry. We set up our number line. And then on the number line, we're just going to use those two numbers. So it doesn't matter like how far apart they are, but 2 and -10. Those are our two numbers, because that's where our inequality equals 0. But now we're looking for where is it greater than 0. So step 4, we're going to pick a test value with each interval to determine the sign of the expression over each interval. So this is what I mean by that. So picking a test value. So somewhere in here, we just have to pick one of those numbers. So I'm going to pick 0, because 0 is in between -10 and 2. It can be any number in that interval. I'm going to pick a number over here that's bigger than 2, so I'll just do a 3. And then over here, I will just do, I don't know, a -12. It doesn't matter which number it is. You can do decimals or fractions, whatever you want, just as long as it's in the interval. And I'm going to take those numbers, these are called test values, and I'm going to plug it in to my original inequality here to decide if it's positive or negative. The answer I get is positive or negative. So like for -12, I'm going to plug it into this expression over here. So it's going to be -12 minus 2, and then -12 plus 10. So you can simplify that, -14 and -2. But really what I want to know, I don't care what the number is, I just want to know, is this answer going to be positive or negative? And I know that 2 negatives equal positive, so I know that this interval is going to be positive, so every number in that interval is going to be greater than 0. Okay, now I do the same thing for this 0. I plug it back up into my original inequality expression. So 0 minus 2 times 0 plus 10. So this will give me -2 times 10. Again, it doesn't matter what the number actually is, but I just know that this section is going to be negative. Every number in that interval is going to be negative. So let's try this one. So 3 minus 2, and then times 3 plus 10, so that will give me 1 times 13, and that will be a positive number. So now that we know where it's positive, where it's negative, we now go back to looking at, what's our next step? We pick a test value. We have to look at what we're actually looking for. We're ready to write our solution, but you have to know where the solution is. So that is where this inequality comes in. So this right here tells me that I'm looking for where that expression is. This is greater than. So you have to know which one you're looking at. We're looking for where this is greater than 0. So, other words, we want to know where it's positive. So we know it's positive on this interval and this interval. So those two intervals are going to be my solution. So I need to write it in two different ways, though. I have to write it in inequality and interval notation. So let's do inequality first. So inequality on that first interval over there is two different pieces, so I have to write two different inequalities. So x is less than, and if this symbol right here doesn't have an equal to, then my answer is not going to have an equal to either. So interval x is less than negative 10. Remember that was our boundary. Okay, or remember if it's in two pieces, we use the word or x is greater than 2, because that was our other boundary. So there's our inequality notation. Now let's do our interval notation. So for that same interval over here, remember it goes low to high, so my lowest on that end is negative infinity with a parenthesis, comma, all the way up to negative 10. But remember, it doesn't have an equal to. We're not including negative 10, so that gets a parenthesis as well. And then we have a union, and then also from 2 to positive infinity. So that would be my solution.